Hi, so let's look at another question in triple integrals given in Cartesian coordinates. Okay, so we have done question one, we have done question two. Now let's do question three. You can check out the link of the two videos in the description. So question three says write six different triple integrals for the volume of the region in the first octant enclosed by the cylinder x squared plus z squared is equals to uh, is equals to 4 and the plane y is equals to 3. Then you have to evaluate each of the six integrals to check if you get the same value. So the idea here is it's interesting because we're only looking at the first octant, so it's kind of like easy. So let's go ahead and do the sketching. I'm almost tempted to use a 3D graphing calculator, but for some of these it's actually okay like this. They are not that hard. Okay, so we're dealing with the cylinder x squared plus z squared is equals to 4, and the plane y is equals to, is it a 2? No, it's a 3. That's a 3 like that. Okay, so this cylinder that we are talking about is something like this. So we have that as our z axis, x axis, no, y axis, then we have our x axis there. Then um, here you have your x axis quite right, you have your y axis, and you have your z axis. So the cylinder that's being talked about is one with a radius of 2. So it simply means we have a 2 in the x, minus 2 there, we have 2 here, and there like that. So you can actually just draw it like this. um, Something like that. Okay, that's pretty desirable. So even if you had to sketch this using a 3D graphing calculator, this is what you'd actually get. Yeah, so it's just more like it's something like that. Then you also have it like that. So it's like the central part is the y-axis. That's what this means. Then you're also talking about the plane uh, y is equal to, so you're supposed to cut the y-axis at what, at 3. So it would be like maybe something like that. Let me see, like something like that. Okay, and remember this is a plane. It's not like just a single line. It's a plane, to be something like that. Yeah, perhaps let me try to use a graphing calculator so that maybe we'll have a wide picture of what this is. um, Let me see. Okay, so we are talking about x squared, talking about x squared plus z squared is equals to 4. That's what we have. Then we're also talking about y is equals to 3. Okay, I can extend it in 3D. It's something like that. So this right here is what we have. Okay, so you have this cylinder that's being cut by, okay, so it's something like this. So this one here is our x squared plus z squared is equals to 4. Then this plane is y is equals to 3. Now we are only focusing our attention on the first octant, so we don't really have to worry much about everything else. So let's head back into into this one here. So when you look at it in the first octant, here's how it's going to be. Okay, all of this I'm just going to erase it. Okay, so of course here we have a positive 2. We have a positive 2 there in the x-axis, as well as positive 2 in the z-axis. Since I'm just focusing my attention on on the first octant. Then let me say this point here is y is equals to 3. So this is going to be something like this. Okay, remember this was a cylinder, it was supposed to be extended. Okay, so we have something like this, and it's going to go like straight in this direction until it reaches where y is equals to 3. Then same is going to go in this direction and reach where y is equals to 3. Then it's going to come like that and go down here like that. You go down here, then you also do that like that. Okay, so this is what we have in the first octant. So remember, our orders of integration, these we have, we're going to start with dz dy dx. We go to dz dx dy, then we'll go to dy dx dz. We'll go to dy dx, no, the other way around now. Dz dx, then we'll have like dx dy dz, then you have your dx dz dy. Okay, so let's go ahead and look at the first one. So again, just like I've talked about these in the previous videos, so it's just about, you look at these two here, you have your dy dx. So what do? Look at it from the xy point of view, like you look at it from the top. Okay, so when you look at it from the top, the only thing that you'll be able to see is this. This is what you're able, this is what you're going to be seeing if you look at it from the top. Let me do this. So viewing it from the top is going to give you something of this kind. It's just going to be more like a box, like a rectangular shape, like that. That's what you're going to, get. Then you observe to say at this point there is some value here and there is also some value here. So the values that are there, this is going to be a 2, and here I've been given a 3. So the outside most, since I've looking at what I've picked there, is dy dx. The outside most is the dx. So in the x, remember this is our x-axis and this is our y-axis. So the furthest I can go is when is from 0 to what? To 2. So it's like from 0 to 2. Then the furthest I can go in the y is from 0 to what? To 3, like that. Yeah, is it? Then the other part, this is our z now. The z is the inside most. So for the z, it's like this bottom part is our base. Okay, that bottom part is our z. Then the furthest we can go up, remember to say if you are going up, you'll be limited by this curve, like you'll be limited by this one here. Okay, so from that you just have to make z the subject of the formula. If you make z the sub of the formula, you do it this way. This is going to be like z squared is to be equals to 4 minus x squared. So z will be equals to the square root of 4 minus x squared. So this will be the square root of 4 minus x squared. So here you have like your dz dy dx, like that. Okay, so what this simply tells us is that if I want, I would swap this to say from 0 now, like I want it to be like dz dx dy. So the outside mode is going to be like 3, from 0 to 3, then 0 to 2 for the x, then the inside most remains the same from 0 to the square root of 4 minus x squared, like that. That's how we get it. Okay, so we're done with this one. So which other one can I look at? Let me look at one of these, then the rest you can just map what I'm going to do on the same. Okay, so hope you have copied this, hope you have written it down. So we erase that. So for the third one, which is this one, I get to look at it from the XZ point of view. Okay, from the XZ point of view. So how it's going to be is like this. If you're viewing it from this side, okay, if you're viewing it from this side, you're only going to see the Z and the Y axis. So here's how it's going to be. It's going to be something like this. Okay, so is it? So this will be our x-axis and this will be our y-axis. So what to be able to see if you view it from this side, this is the shape that you're going to see. It will be something like this. Okay, it will be something of that kind. So you know to say, no. Why am I writing y? That's supposed to be z. So here we know to say we have a 2 and we have a what? We also have a 2 here, and the equation of this part of this one here is simply x squared plus z squared is equals to 4. That's the equation of this one. So if I want to look at I have a situation where the outside most is z. Okay, the outside most is z, meaning I'm starting from 0 to what? 0 to 2. Like this is the lowest I can have, is from 0 going above up to 2. Then the middle part, which is going to be the x, meaning you're going in this direction. You're also starting from 0. Okay, you're starting from 0, but the furthest you can go is limited by what? By that equation there, or this curve. So meaning from there you just have to make x the subject of the formula. When you do so, if you make x the subject of the formula here, this is just going to be the square root of 4 minus z squared. Okay, then the inside most, um, the inside most, sometimes it appears complicated, but on this one it's a bit different because we are starting from, it's like this is going to be our base. Okay, that's going to be our base, then you're going in this direction. Okay, it simply means we are starting from 0. Okay, we are starting from 0. The furthest we can go in the y-axis is what? Is a 3. So that's why we have as our dy, our dy dx dz. Meaning, if you are to do this the other way around, you want to find the inside part can still be from 0 to 3. Then you have your dy, meaning you say dz dx rather. So for the outside part, which is our x, meaning we're going to start from 0 to 2. Then for the z, which is on the middle part, we'll start from this point going up, but to be limited by what? By that equation. So just make the z the subject of the formula. So it will just be 4 minus x squared. Okay, 4 minus x squared. So that's how that comes about. That's the difference. You observe to say here you have a z and here you have an x, and it has to do with what you have here and here. That's how we do that one. Just pick a point of view, becomes your base, then you take care of the rest. So let me actually pick one. I'll pick maybe this same last one to do the evaluation, so that we see what you're going to end up with. We have, this is what we have. Then let's see what this takes us to. So when you do the integration, you say from 0 to 2, 0 to the square root of 4 minus x squared. When you integrate with respect to y, you're going to get a y. Evaluate from 0 to 3, you're going to get a 3 dz dx. Then integrate with respect to z, you're going to get 3z from 0 to the square root of 4 minus x squared. Write down the right thing. 4 minus x squared dx. So evaluate there. This is going to be from 0 to 2. That's just going to be 3 square root of 4 minus minus x squared dx. Okay, so how is this one going to be? So we are moving from 0 to 2. Then we have, actually not, I put the 3 outside here. Then we have the square root of 4 minus x squared dx. I believe the best method that can work here is I would want to use trig substitution. I'm not sure if uh, there's of course there would be another method that you can use, um, that can also work. So let's see how this one is going to turn out to be. um, okay, so here is just a matter of what we are going to allow our x to be equals to. So here in this case, our x, we're going to say our x, since it's a value minus the x will be equals to a sine what? A sine theta. And the way we get our a is this. It's just more like it was a squared minus x squared. So our a in this case is just more like it's just going to be 2, because if you say 2 squared, that's going to be 4. So you're looking for the square root of 4, which is a 2. So this is going to be like a 2 here. Okay, so we're going to put a 2 there, sine theta. So meaning dx will be equals to 2 cos theta d theta. Okay, so this will be 3 from 0 to 2. Then here we are going to put, we say 4 minus, this will be 4 sine squared theta multiplied by dx. We said it's a 2 cos theta d theta, like that. Okay, so what does this give us? So here we can have 3, 0 to 2. This here can be, the 4 can be factored out. Then the square root of 4 is just going to be, we are going to have a 2 here. Then we have the square root of, supposed to be 1 minus sine squared theta. So this here is just equals to cos. Okay, so you can just write it as what? As cos. So that's going to be cos theta there, multiplied by 2 cos theta d theta. 2 by 2, that's a 4. By these 3, you're going to get a 12. So that would be a 12 from 0 to 2. Then you have cos squared theta d theta. Okay, we have to do another simplification here. We can use some trig, let me not erase that. We can use some trig identities to simplify this. So we can write cos squared theta to be equals to 1 plus 1 plus cos 2 theta divided by 2. So this would be like 12 from 0 to 2. Then this will be written as 1 plus, actually, since I'm supposed to put divide by here, I'm just going to simplify to say 2 into 2 is a 1, 2 into 12 is a 6. So I'm just going to put 6 here, then 0 to 2. So we have like 1 plus cos 2 theta d theta. So this will be 6. You do the integration there. This will be theta plus, this will be theta there plus, what is it going to be? Theta, then that will be plus sine 2 theta. Okay, sine 2 theta divided by 2. If I'm writing from 0 to 2 there, like that. Okay, so now I would want to plug in values here, but not just yet. Let me go ahead and determine what theta is in terms of x, because I would want to use an x here. So this tells me to say, if you look at this point, okay, we are saying x is equals to 2 sine theta, so we can say x over 2 is equals to sine theta. It simply means theta is going to be equals to sine inverse of x over 2. So this would be 6, then this would be sine inverse of x over 2 plus sine, you put 2, then where there's theta you put sine inverse of x over 2, like that. Everything here divide by 2. Then now you can divide it from 0 to 2. So just a matter of plugging in here. So it says 6, so sine inverse, where there's x you plug in 2, this is going to be a 1, plus this will also be sine 2, then this also be sine inverse of 1 divide by 2. Okay, so let's see what this gives us. So sine inverse of 1, I'm getting 90. I'm getting 90, so I mean, meaning even this part is going to be this is actually interesting. So we have a 6 here, then sine inverse for this part we have found 90, of which I can just write pi over 2 in radians, plus, so here I'm supposed to write pi over 2. Okay, I'm supposed to write pi over 2, but it's going to be this way. It will be like sine 2, then that will be pi over 2 divided by 2, like that. Then 2 multiplied by this, I'm going to get sine pi divided by 2, which is equals to 0, because sine 180 is 0, divided by 2 is still going to be 0. So this is what I end up having there. So just multiply the 6 multiplied by pi over 2 is going to be 3 pi, and this is our solution, and that's how we do it. So that's all in this video. Thank you very much for watching, and we'll catch you in another interesting video.